Hello students, today we're going to look at some rules of exponents and laws of logarithms. We're going to be looking at both of these today because there's very much a relationship between some of the rules of exponents and the laws of logarithms. We're going to start by looking at 3 rules of exponents, and these are going to help us when we have more than one exponent, but we can simplify the expression to only have one. We're going to look at 3 different scenarios, and with each, we're going to use an example to build a rule that we can use. So first, I want us to look at x squared times x to the 5th. Now, you might know how to combine these into one exponential expression, but if we don't, the way to get an idea of what the rule is to write everything out in its expanded form. So x squared is x times x, and x to the 5th is x times x times x times x times x. Now, when we look at this, this is just a product of x over and over again, and in fact there are 7 factors of x in total, so this is equal to x to the 7th. How can we take 2 and 5 and use them to get 7? Well, we add them. So in this case, we add the exponents. And the rule says if we have a to the u times a to the v, so a product of 2 expressions with the same base, we can combine them into one exponential expression by adding the exponents, a to the u plus v. The reason we can add the exponents goes back to the example that we had. X squared gives us 2 factors of x, and then x to the 5th gives us 5 more factors. So in the end, we've got 2 plus 5 factors, which gives us 7. Now, the reason we want to know this shortcut is because if we have something like x to the 12th times x to the 4th, we're not going to want to go and write out x times 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 x, and then have to count all of those. Instead, life is easier if we use the rule, which tells us to just add the exponents. So here, 12 plus 4 is 16, and this gives us x to the 16th. All right. Let's look at another example, and this example is going to give us another rule. Let's take a look at x squared raised to the 5th power. Now again, you might already know the rule that tells us what to do here, but if you don't, we're going to write everything out in its expanded form. So when we raise something to the 5th power, that means we're multiplying it by itself 5 times. So this is x squared times x squared times x squared times x squared times x squared. And we can expand this even more because x squared is x times x. So we've got x times 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 x. We've got x times x appearing 5 times, and in the end that gives us 10 factors of x. So this becomes x to the 10th. Now how can we start off with 2 and 5 and end up with 10? Well, we have to multiply those. And so the rule that we have here is if we have a to the u power raised to the v power, we get a to the u times v power. We can multiply exponents when we've got one exponent on top of another. So if we had x to the 12th power raised to the 4th power, instead of writing out x times x times x, etc., 12 times and repeating that 4 times, we can just multiply the exponents, and 12 times 4 is 48. All right, we have one more problem that we're going to look at. This one is x to the 5th divided by x squared. Now again, some of you might already know the rule for how to deal with these exponents, but if you don't, we can expand them out to figure out what the rule is. Here, x to the 5th is x times x times x times x times x. X squared is x times x. Now what do we have? We've got 2 factors of x that are going to cancel in the top and bottom, and that leaves us with x cubed. Now, how can we start off with 5 and 2 and end up with 3? We subtract, and you can see the reason we're subtracting is because we started off with 5 factors of x, and those 2 canceled, taking them away, leaving us with 3. And so the rule here is going to be a to the u over a to the v equals a to the u minus v. If we have a quotient of 2 expressions with the same base, we subtract the exponents. And so if we have x to the 12th divided by x to the 4th, we can combine these by subtracting the exponents and getting x to the 8th. These are the 3 rules of exponents that we are going to need moving forward when we're dealing with logarithms. There are actually a few more rules of exponents that we could look at and that become useful in various situations. But because we really want to be focusing on logarithms, I've decided to focus on the rules of exponents that are going to be the most important for us. If you want to look at other rules of exponents because you're curious, you can look in the textbook, which lists all of the rules out, giving plenty of examples. But for right now, I'd like you to get just a little bit of practice with these, and then we can move on to looking at laws of logarithms, which are very much related to these rules.